Hello everyone, welcome back to another video with Mr. Coder, and in today's video, I'm going to show you how to solve color rows and columns. Question F from Codeforces Round 966, Division 3. So you have n rectangles, the ith of which has a width of a of I and a height of b of I. And you can perform the following operation an unlimited number of times. So you choose a rectangle and a cell in it, and then color it. And each time you completely color any row or column, you earn 1 point. Your task is to score at least K points with as few operations as possible. So suppose you have a rectangle with a width of 6 and a height of 3. You can score 4 points by coloring all the cells in any 4 columns, and thus performing 12 operations. So that because it's 3 times 4. So that's the first example, and then 1, 5. You need 5 points on a 4x4. So then you can do 4, and then you realize that it'll be a 4x3, which means that 3 will be shorter. And then you keep doing that, 3 plus 2, and then 4 plus, so yeah, 4 plus 3, and then you'll keep going down like that. And then 3 plus 2 plus 1. So that'll end up being 14. Because like you always want to greedily do it. So then you'll end up needing to fill up the 14, any 14 like cells. Well, actually 14, like if you brute force it, like 14, which means that only 3 of them won't be there. And then what happens, like if we discuss like what happens if cases where it doesn't work. So like for example, this case right here, it won't work because like 1 and 2, you have a maximum of 3. You can get 3 total maximum. 5 plus 6, you can get a maximum of 11. 11 plus 3 is less than 100, which means that you'll never be able to reach this K, so that's why it's -1. And how many, like another thing is how many rows plus rows and columns can you get total? Well, that'll just be the sum of all widths and heights. So then you can check that beforehand to see if it won't work beforehand. And then this problem seems like a DP problem, and if you thought so, then that's how you do it. It's basically kind of like a knapsack DP. So first you get the width and heights in, and then you add it to the sum. You check if the sum is less than K. If that's the case, then it won't work. Otherwise, you do a DP of like K plus 206. I just did that, so like that'll have extra room. And why specifically like above 200? That's because like 100 plus 100 is 200. Like it might be more optimal to like go ahead of K instead of like it could be more optimal to like, go ahead of K. So I just like left that in just in case it was more optimal to go ahead of K. And then you always set DP as 0 to be 0 as the base case. And then you'll since like the constraints are pretty loose with n less than or equal to 1000, K less than or equal to 100, and the widths and heights being less than or equal to 100. So then I looped through each n, and then I went through each possible amount it could be, like each possible amount of points you could take from it. And the maximum is W of H or W of I plus H of I. And then I just kept seeing like what's the minimum and then keep updating it. And then I went through each and then I had to use a different one since you can only use one of each amount. Like you can't use like 1, 2, and 3 from this amount because then you might not have enough. So that's why you have to create a copy of the DP array. And then you go through each possible amount, and then you go through in reverse from K plus 205 down to 0. Then you see if L minus J is greater than or equal to 0. If it is, then you can test it out by having this updated DP of L as the minimum of the current update of L, and then this has to be a DP array, because you can't like use the updated stuff with it. So it'll be DP of L minus J plus amount of J, and then you convert it back to DP equals updated, and then you check what is the minimum among all K possible Ks for like from K to the maximum, because like anything above that can work. And then you just get the minimum of all that, and then you print the minimum. So yeah, and then if you run it, that basically gets the correct answer. 12, 14, 5, -1, 17, 80, 35. And this, even though this might seem slow with 3 for loops, because usually like with this complex type of problem, this higher level problem, you usually can't do that. But in this case, it's 1000 times 300 times 300 basically. So at worst case, which will be around that'll be around 9 times 10 to the 7th, which is nearly like 10 to the 8th, which generally works because even though t is less than or equal to 100, but the sum of n across all test cases doesn't exceed 1000. So that's why this works in time with plenty of time to spare. It ran in around 62 milliseconds. So yeah, that's basically how you solve color rows and columns. It's basically knapsack BP, a little bit of a variation of it. So yeah, thank you for watching this video. If you like this video, please like and subscribe, and I'll see you in the next one. Bye.